Hello, welcome back to another episode of Math with Hoss. You're watching Precalculus, Season 2, Episode 18, Part 1. We're continuing our investigation in trigonometry. And what we're going to do now is work through some examples of how to come up with graphs of trig functions with their transformations. In the previous video, if you want a quick reference at the end, so this is episode 2.17, we gave a nice summary of all of the transformations for sine and cosine, so I'll refer you to that video since it's already there, and that way we're just not repeating information. Because what I want to do in this video is focus strictly on kind of a way of thinking about these problems in order to effectively graph them. So that's what episode 18 is all about, and that's why I'm calling this part 1, because this video part 1 is going to be just one example, part 2 will be another example, and I can add more examples later on if needed, if I get a lot of interest in that. So for now, we'll definitely do a couple sort of difficult problems. So what we're first going to do is consider the following. Function y equals 3 sine of how about 2x plus 1. So whenever you're given one of these, and so we're asked to graph this. So whenever we are given one of these trig functions with transformations and we want to graph it, first step is identify the transformations. Alright. So to identify the transformations for step 1 here, we want to know we have a 3, a 2, and a 1. In fact, now I think that we should color code this. Okay. So this 3 here, if we recall our general equation, that's actually going to be our a. So this tells us that a is equal to 3. In fact, let's state our general formula: a times sine of b times quantity of x minus d and quantity plus c. So with this a value, this is going to tell us that when we take the absolute value of it, this tells us that the amplitude, so this is equal to 3 and this is equal to the amplitude. Alright, so that tells us our graph has to have an amplitude of 3. When I consider this quantity here, this is our b, and I just noticed that this parenthesis looked terrible, so let's fix that. That looks better. So b is equal to 2, and this tells us that the period is equal to 2 pi divided by 2, which is equal to pi. Okay. And then the last thing to note is that c is equal to 1, and since c is positive, we know this is a shift up 1 unit. Alright, so that is step 1. We looked at what's given, and based off the quantities given, a, b, c, or d, we identified what was going on. So we notice there's an amplitude change, there's a period change, there's a shift up. It's a lot going on. So that raises a question. We've identified our transformations. Our second step is draw the original graph. Alright. So to draw the original graph, we're going to scroll down. Here we are. Now we are given sine, right? So we had a sine function, so we need to start with the original sine function. So here we go. Here is sine. And we need a label, of course. There's pi over 2, pi, 3 pi over 2, and 2 pi. 1, and negative 1. Now, once we have our original graph, so that was step 2. So I guess we can note step 2 over here. Though we're going to put all future steps on top of this one. Okay. In fact, when I'm thinking about it, I think what we want to do is select this graph and move it down. So, because we're probably going to need more room. And so now we're going to come back to step 3. So step 3, we need to work through the transformations, and we're going to work through them one by one. So we're going to graph the transformations one by one, and we're going to do this by adjusting first the original graph, and then the graph with the first transformation taken into account, we're going to modify that with the next transformation. And then we'll take that curve and modify it with the next transformation. And as we go through this process, in the end, we'll have our completed graph. So the order of procedure, how I like to think about it, is start with the most complicated and end with the easier ones. So the two most complicated changes are going to be the period change and the horizontal shift. So I recommend that you start with either the horizontal shift or the period change. So the period change or horizontal shift. So we call this A, B. I would say do the shift up or down. Up, down. C would be the amplitude changes. And then the easiest one after amplitude is going to be the reflection across the x-axis. Alright, so that's kind of how you want to think about it. Start with the period changes and horizontal shifts. I'm not sure which would be better first, thinking about it right now. So just consider them both. I'm just going to consider them both as the first step. Then I think the shift up and down and the amplitude, those are both really easy, but I think it's better that you do the shift up or down first and then do the amplitude change, because I've noticed some students, they get mixed up the amplitude and the horizontal shifts, like if they do the amplitude first. So that's why I'm saving the amplitude for after the shift up and down, because I know some students, they get things mixed up in their head, and so this is just to avoid. Then of course the last easiest one is the reflection, which we don't have in this problem. Alright, so step 2, we have this. Step 3, we want to start with our period change. So effectively, what is happening is, what used to be 2 pi is now pi, right? And what was 3 pi over 2, we could think of that value as being halved. So each of these original values, the pi over 2, the pi, the 3 pi over 2, and the 2 pi, since the period changes, since b is equal to 2, we're effectively taking each of these values and dividing by 2. So our transformation means this is going to behave, or when we hit pi over 4, that's going to behave like pi over 2. When we hit pi over 2, that means it's going to behave like pi. 3 pi over 4 is going to behave like 3 pi over 2, and pi. So we can think of it this way. If we want to graph y equals sine of 2x, okay, then when you plug in pi over 4, that's going to be the same thing as sine of pi over 2. Right? That means for our pi over 4, we're already up here. And our pi over 2 is going to be acting like a pi. And then down here we have 3 pi over 4. That's going to be down here at 0. So we're now saying that when we get to pi over 4, it's like we're already hitting the value at sine of pi over 2. That's because we're thinking pi over 4 has to be multiplied by 2. So that's what this is going on. So you could think of it as if we take our original values here and divide them by 2, that'll give you where at is the period change. So if you took every single one of these values divided by whatever b is, that'll give you your new values for the corresponding x values, and the y values will stay as whatever the original x values were. Or you could just make a table and think, if I plug in pi over 2, what happened, or if I plug in pi over 2, what happens to that. So, but I think this is a quicker, more effective way. Just think about what happens to these original 5 values. Well, they're all being divided by 2. They're being divided by the b value. So that takes care of A. Now we have a shift up and down, so we're going to now do that shift up. So note, since we have a shift up 1 unit, so shift up 1 unit implies, I don't know why I put a y there, that's going to imply we have y equals 1 for the midline. So I'm going to put, here is 2. Our midline is now going to be here. So before, our midline was at y equals 0. And the midline, you want to think, is the line that effectively cuts our graph in half. Now to account for the shift up 1 unit, what we're effectively going to do is add one unit to every y value. So when we start right here with this point, our y value is 0. So when we add 1, it's now up here. When we start with the x value pi over 4, we are at 1. So then we add 1 unit and we are now up here at 2. When we are here at pi over 2, we're at 0, so we add 1, and now we're up here, and we continue this. So this green line now, which is not very curvy at all, so that's bad on my end. So the green line now takes into account this graph here, sine of 2x plus 1. We took into account the transformation of the blue line. That was the period change. And now, on top of that, we moved it up 1 unit. By working through these problems slowly, one transformation at a time, we're not rushing it, and we can carefully look at what's going on and be able to come up with our nice graph. This is something we just don't want to rush, so that we can carefully see what's happening, right? we started with this black line, we did the blue line, now we have this nice green line that's going off into what's next. Okay, so now we need to do the amplitude change. Alright, so I'm going to move this y equals sine of 2x, and we need to make a little bit more room. So let's delete that. Alright, so when we think about the amplitude, this here, that is a unit length of 1. That is an amplitude of 1. So to get an amplitude of 3, what you need to do is go up 1, 2, 3 units. So right here is 3, up here is 4. That means we need to have a point up here. So notice I start at the midline and I count up 1, 2, 3 units. Now the points that are on the midline are not affected at all. So now when we think about our point over here, right? So we have a point that's -1. We have to go down -3 units now. So notice we need to go down 1, 2, 3, and make a point right here. So that is at -2. So we've gone up and down. Alright, so now I'm going to clean this up a little bit. We're going to get rid of this line here in the middle, just so we can see a little better what's going to happen. And let's fix this line. Alright, let's fix this point. So this point, and this point, these 3 points on the midline, they do not change because you did not go up or down at all from the midline. So now we get the following graph here, and this takes into our account the change in amplitude. So this purple line is y equals 3 sine of 2x plus 1. Now this here is what we were interested in, right? This was the original graph. And so now we are done. So by walking through it step by step like this, we can get our graph rather easily. And we're going to just highlight our final one. So let's pick a different one. That didn't really show up too well mostly. So this curve here that I'm highlighting, that is the final answer. Right? So we can see that nice and clearly now. So that is how I would recommend that we graph it. Just walk through it step by step. Alright. Thank you for watching this video. If you've been enjoying our content, please subscribe and consider supporting us on Patreon. Thank you for joining our math party, and I will see you next time.